We're still just building on some stuff that we've already learned. So we're going to apply our exponents in our power equations. Well, if I take a look at both these are power equations. Remember, power equations are when our variables are to like a number, where our exponent equations are when our number are to a variable. Those are the difference. So power means it actually has a power. Exponent means our exponent has a variable in it. That's the only difference. So we should be familiar with how to solve both these, right? One of them has it written with an exponent, and remember we just want to get that exponent to 1. So how do I do that? I go to the power of its reciprocal. So 4 to the 1/4, and we do that to both sides. And we could just go ahead and use our calculator in that case. And over here, when it's the root, and it's the root 3, remember I could rewrite this as x to the 1/3 power, right? Because it's really, to the first power right here. And I could write it as a fraction. And then I could take it to the 3rd power, or right off the bat, I could just take both sides to the 3rd power and be done. Okay, so hopefully we're good with that kind of stuff. So we're not going to spend too much time with that. So same thing. Let's just quickly talk about how to solve these. So up here, I would just take this 2. Well, I got to get it to x to the positive 1st power. So how do I do that? Well, I have to multiply negative 1/4 by negative 4. So I got to take it to the negative 4th power. So I'd really take this to the negative 4th power. So we're not going to go through and solve, and then just treat these just like you would algebraically, right? You'd add 8 over first, and then divide by 0.75, and then take it to the 1/5 power. So I'd take all that to the 1/5 power, so on and so forth. And same thing with this last one, right? Just follow your algebra rule. So I'd have to divide by this 1500 first. I can't distribute it because I have an exponent here, so no distributing. So divide by 1500. And when I use my calculator, I get 61 over 60 because I get a nasty decimal. So I'm going to leave it as a fraction simplified. Well, a couple ways to do this one. So I could either switch my exponent and write it as an improper fraction. That's one way. So I could rewrite this problem as 1 plus x over 12 to the 13 over 2 power. Because then I could take both sides to the 2 over 13 power, right? Take it to its reciprocal. That's one way to do it. The other way to do it is just think of this as a fraction, right? It's really like 6.5 over 1. So I could take this whole side to the 1 over 6.5 power. So I take this whole side to the 1 over 6.5 power. And then what would I have left in this case? Well, that gets rid of my parentheses in the exponent, right? Because these cancel each other. And this is where you just have to be careful how you type it in. So I'm going to go 61 divided by 60. I'm going to make sure that's in parentheses to the, and remember, if it doesn't pop up like that, you need to put it in parentheses. Okay, depending on what your mode is. Since my mode right now is in math print, it goes to an exponent. If it's in classic, it wouldn't go to an exponent. So you just have to be careful. So I'm going to go back up into my exponent here. So 1 divided by 6.5. Enter. So instead of rounding this, let's get good at just using our calculator with what we have. So if I look at my last steps, what am I going to have to do? I'm going to have to subtract 1 and then end up multiplying by 12. So just by mentally knowing what my next steps are, I should be able to just subtract 1 from my last answer and then multiply by 12 to get an answer. So x equals 0.3. If we round too early, we won't get a good answer. Okay, so make sure, try not to round until the very end. That's important. All right, so problems like these, you're going to be expected to solve without a calculator. Okay, and so let's take a look at this first one. So remember, since there's no adding and subtracting, I can give the 2/3 to both these. So really, I have 8 to the 2/3 power. And then remember, when it's a power to a power, what do? We multiply. So 9 times 2/3 is 6, right? A third of 9 is 3, and then 2 of them gives you 6. So you can multiply 9 times 2/3 if you want. Well, then if we remember, I can rewrite 8 and 2/3 as, the third root of 8, and then square it. Well, what is the third root of 8? Or basically I'm saying, what to the 3rd power gives me 8? Well, 2. So I'm replacing this with 2, and I got to square that. So I really get 4x to the 6th right there. So that is my solution for this guy, 4x to the 6th. So you're going to be expected to do that mentally. And how I would do that is I would rewrite it just like I did right here. And then I like to do this. Well, what to the third power gives me 8? 2 does. And then I square that number, just like I did down here. Okay, so let's try another one. I'm going to try to do this without rewriting a ton of stuff. So I'm going to take this to the 4/3 and this to the 4/3. And I should still have this negative 27 in parentheses to the 4/3 because it was in parentheses prior. That's important. And x to the, well, 4/3 times negative 9 gives me negative 12. And now if I think about, what to the third power gives me 27, what's the third root of negative 27? Well, 3 times 3 times 3 is 27, and they all have to be negative. So negative 3, and I still have to take that to the 4th power. And I still have, well, I can get rid of this negative exponent, right, with this guy. I just have to move it to the bottom of the fraction. So I really has to come down here and become x to the positive 12. And then negative 3 to the 4th power gives us 81. So 81 over x to the 12. And for right now, you can check using your calculator, but you won't be able to use that on your test. So just get used to working with these mentally. Going on to the next one, distribute. Or even before I distribute, what could I do? Could I get rid of this negative exponent? Sure. I could rewrite this as 1 over 16 to the x to the 28th to the positive 5/4. So that becomes positive now once I flip it. And now I can give this exponent to everything. So the 1 doesn't change. And then I got 16 to the 5/4. And x, well, a fourth of 28 is 7. 7 times 5 is 35. And then what's the fourth root of 16? Or what times itself 4 times? 2. And I still have to take 2 to the 5th power, which gives me 32. So this would become 1 over 32 times x to the 35th power. Okay, so these are getting a little bit tricky. You just have to think a little bit, take your time, and I think you'll get good at them. All right, just a couple story problems here. It says, find the annual rate of inflation to the nearest 1/10 of a percent. So we got a cost of movie ticket increase from $6 to $8.50 over 10 years. We're going to find that percent rate of inflation. So first of all, we have to remember our exponential equation right here. A times b to the x. So our new value is 850. That goes in for the y. Our original was $6. That goes in for the a. And we're trying to solve for the b. Well, remember, it's inflation, so it's going up. So it's going to be 1 plus my rate as a decimal. Okay, remember that back to our recursion for that 1 plus, r, or 1 minus r if it's, depreciation, things like that. And then to the x power, in this case, t for time, or you can use x, it doesn't matter. And I already know that's what, 10 years, so I got to plug in 10 for that exponent. All right, so now let's, get our variable by itself. So I got to divide by 6 right off the bat. And I get a nasty decimal, which I change to a fraction, and I get 17/12. And then it looks like to get rid of this 10th power, I got to take that to the 1/10 power. So take both sides to the 1/10 power. And now I can't change it to a fraction, but I end up getting 1.03. I'm just going to write out, a handful of decimal places. 544, so on and so forth. And that equals 1 plus r. And then I just have to subtract 1 from both sides to find my rates. So really I just take what I have on my calculator and subtract 1, and I end up with about 0.0354. So r equals 0.0354. And to find a percent, we just move it 2 to the right. So that would be a 3.5%, because right, it said to the nearest 1/10 of a percent. So 3.5% increase of inflation. So there we go. So we're kind of using our recursion thought.